You're on.
All right. Hi guys, good to see you again. So you guys, as many of you know, I've relocated up to Denver, at least for work days, and working on robot trucks these days. And so what I'm going to share here is what I've learned about the use of Matlab and Octave for the analysis of robots, and why you want to use it, how it's a whole lot better than alternatives. So we're going to do overview and compare Matlab and Octave, and show why it's useful, how to acquire and download each of them, how to start each of them. So I'll be doing side-by-side demos of this is what it looks like in Matlab, this is what it looks like in Octave. And then we'll get into some of the language. So there are really three aspects to this talk. The first is the Matlab language itself. Matlab is a language, and so we're going to go into hopefully enough depth of the language to allow you to use it by referring back to the slides. The second is the use of the programs. Matlab is also a program, a software that runs the Matlab language, and then Octave is the open source version of the Matlab software for running programs written in Matlab. And then the third element of the talk is going to be stepping through a real program operating on real robot data and showing what it shows, and looking at the syntax, the commands, and understanding how to read and write the Matlab language. I hope with that as a background and the slides as your reference, that you'll be able to actually use Matlab or Octave and do things like plot where your robot thinks it was versus where perhaps GPS says it was, what the PID loop, your PID loop internal state variables are doing over time as the robot progresses through time, and plot each of these against each other over time. That's really the goal here of using Matlab is to view your robot's performance at a higher level and a more analytic level than it kind of looked like it went where it was supposed to. So I don't know how far down here we'll get, but there's a fair bit of material, so it's going to be a bit like drinking from a fire hose. So sit back, relax, put on your thinking hats, and let's go for it. So Matlab, differences between Octave and Matlab. They both run the Matlab language, but there are some minor differences here and there in how they behave or in some of the more obscure commands. The biggest difference is that Matlab has a tight integration with a simulator. It's called Simulink, and it simulates just about anything. They've got simulator packages for control systems, aircraft frames, fluid dynamics, you name it. There are simulator packages for it. And when you do it that way, you use Simulink as a simulator, exporting its data to Matlab for analysis. I'm not going to go over that. I'm only going to do Matlab. I'm also going to assume that you'll be writing a script, that you'll be writing two pieces of software. One to run on your robot and collect the data from your robot, like its odometer counts, time, GPS readings, compass headings, etc., and write it all out to a file. And the second is a Matlab script to analyze that data and show you how how the robot really worked, as opposed to, well, I think it jiggled there. Matlab has an IDE. It's very GUI-ish, and I'll show you that, how to work the GUI. It has windows that I'll show you in a sec. They both have an integrated debugger. So this tutorial applies to both Matlab and Octave, unless I state otherwise. I'm going to show you how to use both programs, but the language I think at the level that you use it, you'll find that there are no differences in the language. The only differences will be in the operation of the programs that you run. So why Matlab? Well, all of us have written this kind of a view of data, scrolling up off the screen. The problems are, the screen dump is narrow. You typically only put half a dozen fields on a line because otherwise it wraps and you can't follow, and then you're like eyeing it as it's scrolling by, or if you capture it, off of the screen capture, then you're like paging down. Basically, you can't get very many columns, and there are a lot of columns of data in a robot that you're interested in for robot motion. It's really too low level. Excel is good at looking at low-level data. It does let you hide uninteresting fields and do simple computation. So I want to just pop out, and give a little demo on how to use that, because I actually do use I do use Excel. Where is it? I guess. Okay, so I actually use Excel when I want to look at the real data, at the real low-level data. So I've collected some data, I've looked at it in Matlab, plotted it, and I see that at time 200, it's doing something. It's like zigging sideways. Well, why is that? Well, the encoders get a jump in their spike, in their delta. So, is that really happening? Is my script broken? So I want to show you a couple of, real quick, couple of quick tricks to help you use Excel on this data. So I'll write the data out in a comma-separated file, a CSV file, and I'll write a ton of fields. You can see, the encoders, the motion status, the odometer, the GPS, the fused XY coordinates from GPS plus IMU. So a lot of data there. So first of all, you hide the stuff that's not interesting. And then kind of nice little trick when you're looking at odometry is to, you're not really interested in in the fact that the left odometer currently reads 57.42.808. What you're interested in is the delta between those. So what you can do is say, make a new column and say equals K3 minus K2, and then if you click on the bottom corner of that, it fills it up, and then you can scroll down and you can look at what. Oh, the other useful thing to do is to freeze the top row. Oops, that wasn't good. I really want to be up top. Freeze the top row. So now you can scroll down and have a look. Okay, so here we see our new delta encoder field being printed out, and we can scroll across and say, okay, what was GPS saying? What was the velocity saying? A little tip for using Excel. Okay. So getting it, Matlab. This is really what you're aiming for in Matlab is plots. This one's XY position. This one's vehicle heading versus time, and this one's vehicle speed versus time. Other interesting plots would be PID variables versus time, etc. Gives you a high-level view of only what's interesting. But the important thing is you you can capture a ton of data and then just analyze the bits of it that you want. And you can derive additional data that's maybe not in your original capture, like acceleration. So, Matlab looks like this. You've got a it has the IDE, it's very GUI-ish, and it tells you what directory you're in. It shows you the files in the directory, and you can click on them to open them up. For example, if you want to open up our plot nav simple script, you just double click it, and hey presto, you get a window. The window has debugging options, run options. It's got a command history window, so you can double click on the command history and it'll show you variables in this workspace area. And then, but the command window is the main place where you initialize or where you run the programs. And so an up arrow will just play back through history, and so we can fire off that plot. And the usual way of using it would be have a look at a figure you're interested in, and a left mouse click. So let's look at 0, 0. Left mouse click and drag should, go into zoom. And now here's the start and the end of the run. Cool. And you're starting to see the ability to really zoom down. You say, what's going on there in that little area? Well, look, this is actually where, so blue is GPS, and this is actually where GPS was jittering around as the vehicle was sitting stationary at the beginning or end of the run. And you can see that it's, looks like it's jittering about 20 centimeters in the Y direction and about 20 centimeters in the X direction. So this was an augmented GPS, but you get the idea, and then a double click will bring you back, and then you can go and drill down into just, so here we are in an area, and you can pan around with the hand button. So this is like the intended outcome of being able to drill down into arbitrary levels of the data that you collected from your robot. And then double click will take it back. So okay, that's a quick demo, the 20-second demo of Matlab. Matlab is great. The other thing is help. Got great help. I usually go into the Matlab section, and then you've got sections on language fundamentals, math, graphics, programming scripts. That's probably about as much as most of what you need for learning Matlab. It's very, very well documented. Okay, acquiring Matlab. You really, for hobbyists, the student version is really what you want. The student version is available, so here's the text of the license that I pulled off their website. Any student who's currently enrolled in a degree-granting institution, high school, or continuing ed program is eligible to purchase them. High school teachers can purchase and use it for teaching purposes. It's $50. If you buy Simulink as well, it's $99. Simulink comes with all of the packages. This is a multi-$1,000 software package, so it's a very good value at this price. As long as you get the license. Now the way it works, you go to mathworks.com. You can purchase it. You put it in your cart. You buy it, and it's instantly active for 30 days. You have to register it to keep it alive. When you register it, you'll need to provide the name of your educational institute, what year you're going to graduate, etc. And then after a while, they'll email you back and you provide the serial number that you got in email when you bought it, and they'll provide a key that makes it permanently active. So I showed just double-clicking it and running a command. Useful commands are help, or help and a command name. Control-C will exit out of some script that's stuck, or quit to exit. Okay, Octave. Let's jump and do a quick demo of Octave. So it has to run, as best I can tell, in an X window, not because of Octave itself. Octave will run in a Cygwin window, but because Octave relies on GNU-plot to do the plotting, and GNU-plot seems to want to run in an X window, at least when invoked from Cygwin. I've read that there are ways at least when invoked from Octave. I've read that there are ways that Octave can call wGNU-plot, and if someone figures that out, maybe publicize it to the group, but I couldn't figure it out. Okay, so I was going to make this black on white, so is this somewhat visible? Maybe if you come up closer, if you can't see it, because I've made its font size as big as I can, and
if you're having trouble, these seats over here are available too. Yeah. Right here, real close.
Because you know, everything we're going to do on Octave is going to happen in this window. So I'm sorry.
Paul,
yeah.
What happens if will it hurt your presentation if you make that window full screen?
No.
Well, that might be nice. Put him off the screen.
Can you get the camera closer to it?
Well, the problem with full screen is I can't see the command line.
Yeah, you might want to shrink it.
I can't see the
Yeah.
Yeah.
Okay.
I've got it on the hugest font, but it.
Okay, Paul, I'm going to change the video so that it's just the frame.
Okay.
We'll maximize what we can see.
All right.
And Paul has the slides he includes, which obviously he's using actual demonstrations, but the slides we'll make available. Right,
yeah.
Paul?
Yeah. Along with a program and a set of data that you can do these kinds of operations. It won't be the exact same set of data I'm using here, but it'll be comparable. Okay, so Octave remembers, like MATLAB, Octave remembers the history. Its command history actually goes back beyond the start of the current session to previous sessions. So it's kind of nice. We can run this plotnav simple script and give it the drive loop.csv file it's the same file that we were looking at in Excel. And where it'll go and plot it. And there we have our plots. So again, the intent is the same. You know, the use is the same as with MATLAB. It's you know, drag it out and have a look at exactly what where it is and what it thinks it is to any arbitrary degree of precision. One thing that is different, because it's using GNU-plot, the buttons that you use for zooming in and panning around are different than they are in MATLAB, and you get help by pressing H in the figure in the plot window, and then it prints out help in the MATLAB, in the Octave window. And so the most important command is A or E, which brings it back to full screen. So like our plot down here, we want to hit A, and then we'll get back to the full screen. So, and then the other, those are the ones you really care about, because typically you're zooming in to some region of interest, and then you want to pop back out to the whole thing, and then look again at maybe some other region of interest. So that's the basic operation of running scripts in Matlab and Octave. If anyone has any questions as I go along, feel free to interrupt me. I'll clarify where I can. I'm not going to go dig too deep into like tangents, but because we've got a lot to go through. Okay, so here's how you acquire and install Octave. You install Cygwin, that sets you through a bunch of setup stuff, and then gives you a search box. You search for these 4 programs and install them. There's a link here to Octave for Microsoft Windows, which has some helpful tips in case you run into problems. Then you can start it with, if you start it with startx, this is a minus to indicate that what follows is parameters. Multi-window clipboard starts an X window, that then you type Octave in the X window, and then you're in Octave and you can print your commands. And just like in Matlab, help and some command name works good. Documentation, help or doc, talked about. Here's the URL of the Octave documentation. The Matlab is documented. I showed the Matlab online help before. So this is the Octave documentation, and it's really extensive. Getting started, simple commands, examples, you name it. So full set of documentation there. But both are really exceptional programs in terms of their quality. Just a minor point: the help text of Matlab functions tends to use caps, but actually the function names are lowercase. It is case sensitive, so don't get confused. Some key points about the shells. So I showed that Matlab has that command window. I think of it as being a shell. You run Octave in the next window, and I call that a shell. So both of them have autocomplete with a tab to complete, and if you type the first couple of letters, then and then tab, it'll autocomplete to that. Both of them have history, both up arrow for previous, and then start letter sensitive. So if you last run plot, then you type PL, and then tab, it'll PL, and then arrow key will show you all of will cycle through all of the plots that you've done. Matlab, you can double click in the command history window, which is very convenient. Octave has a history command and a run history and give a history number command. So both of them good history support. You can create variables on the fly. You type a variable's name to print it. Okay, so there's some special things here I want to just show you because they're kind of key to understand. Okay, so we're in Octave here. If we say A equals 2 plus 3, it answers A equals 5. Whenever you don't give a semicolon on the end of a line, it prints the answer to that right away. The semicolon suppresses the output. So that's why in scripts you typically see semicolons after each statement. It's not a statement terminator like in other languages. It says don't print the output. Now, I just, by printing a equals 2 plus 3, I declared the variable a. So it's like many scripting languages. You just, like, a variable is created when it's assigned. And you just type the variable's name, a, and it'll tell you what a is. So a can, that's how you do debugging. You know, if you want to know what the value of some variable is, you can type the variable name or the, yeah. Also, it's got Linux-like cd commands and directory listing commands. And this is true of both Matlab and Octave. So you can do an ls and a pwd to print the working directory. You can cd to ... wherever uses a / for directory path separators. Okay, so that's the special key points that you'll use every day about the shell. Okay, so Matlab is a compression of matrix laboratory, and Matlab thinks about everything as being matrices. And matrices can be matrices of complex numbers. Strings are matrices of characters. They're 1 by n. It does have structs. Vectors are a matrix with 1 column or 1 row. Scalars are a 1 by 1 matrix. Integers, you don't need to worry about chars or shorts or ints or longs. In Matlab, everything's a double float. And Boolean is either 0 for false or not 0 for true, a bit like C in that regard. So almost everything is a matrix. To create a matrix, you just have to type, okay, so there's a couple of key points here, syntax elements that you'll see over and over again and that you'll want to remember in order to read Matlab programs. So this is an assignment to the variable a. The square brackets are the concatenation operator. So it means concatenate all of these things into a matrix. Commas or spaces are delimiters between elements in a row, and a semicolon delimits a row and starts the next row. So, this would create, this says concatenate 8, 2, and 1 into the first row, 3, -1, and 4 into the second row, and 7, 6, and -5 into the third row.
Two questions, quick.
Yeah.
So 8 space 2 space 1 semicolon would be equivalent to the a comma.
Yes. Yeah.
Okay. Are they? And I'm assuming that variables are case.
Yes. Variables are case sensitive.
Okay.
Variable names are case sensitive.
Okay.
Yep. And so we can do this real quick. Just. And there we see it created it, and because we didn't put a semicolon on the end, it printed the output of the assignment, which is the value of the matrix. We put a semicolon on the end, it doesn't print anything, but A still exists. If we type A, oops, that's lowercase a, which is 5, and uppercase A is that matrix. Okay, so there's, you won't have much use for manually creating arrays unless you may be making a Kalman filter or something, but it's good. But you need to understand these array operators.
So when you did that second time around the A, I assume you override a petrol the A that was there before.
Yes. Yes. And in fact, you can change the type of a variable. So you can change a matrix into a string. You know, just like in most scripting languages, you know, when you assign to a name, the name or the type of the name is set at assignment
So
time.
you actually could make that into like a float thing if you type A equals 8.2.
Yeah,
or something.
yeah. Then it would be. Yeah.
Okay.
Well, it's already a float actually, but
I get
because
it.
everything's a double.
Okay.
So here's our character string. And just assign it, use single quotes. Octave actually supports double quotes, but don't use them because MATLAB doesn't. So you know, just keep it compatible and use single quotes.
So I'm assuming you're doing this to show, like, you know, you can do matrix manipulations with very large matrices.
Yes.
Then?
Yes.
Okay. So so what's the source of that data? Is it a file or?
Yes. So we're very shortly going to step into the file that I was running, and the way I intend to run this. I'm sorry, I didn't explain this earlier, but the way I intend to run this is to go through the file a few lines at a time, and then through the corresponding MATLAB language definitions, the related MATLAB language. Things like how to manipulate matrices, and do them side by side, and we'll step through so that you can, at the end of this, I hope you'll be able to read that MATLAB script and understand it, because we will have done the code plus the MATLAB language elements side by side.
So you're just walking before running.
Yeah. Yeah, so right now I'm just setting up some basic things, some basic assumptions about the shell, paths, data type, variable types. Yeah, so here's the point that s equals 3 followed by s equals, in quotes, octave is fine because it just changes the type on the fly. You know, it was a 1-by-1 matrix of a double, and here it becomes a 6-by-1 matrix of characters. There's a who command that's useful. It tells what variables are currently defined. So I'll jump back to here and type who in Octave, and we have capital A, lowercase a, ants, and packages dir are the variables that are defined. And I believe there's also a who's. Yeah, that tells you more about them, tells you the size of each. Big capital A is a 3-by-3. So that's useful if you, so like most scripting languages, you can execute them line at a time. So you can like cut them out of a file, paste them into your shell, and run them one line at a time and see what the results are. Also, when you stop at the debugger, set a breakpoint or you stop on error, you usually want to know what variables are defined and what their values are. So who and whose will tell you the variables and what size they are, and you can type the name of the variable and get its value. Okay, function scripts and debugging. So here's where we're going to jump into the program that produced those plots. Functions and scripts are a little bit different, and I'm not really going to talk much about scripts. I've really only used functions, but they're all defined, both are defined in external files, but you call them from the command line, or from a script, just like a built-in function. So where from the command line you saw me type plot nav simple, and then the parameter was the file name of the data file name. You could also call that from within a higher level script. So if you had a higher level script that was doing some processing, just call it the same way. A function has a function and the name of the function, then the body, and then end. You always, or most of the time, you define one function per file, and the files end in a .m is the suffix used by convention. So don't put a bunch of functions in one file. Passing parameters, you invoke the function name and give it an argument list in parens, and if it has just a single return value, you can put the variable name there, or if you put this concatenation operator, the function can return multiple values, and they'll be assigned into the list of variables that you put inside the concatenation operator.
Wait, on this one, Paul, I'm a little confused. Okay, go back one slide. Okay, so here the syntax is function name. Okay, so now go to back to the slide that you had.
This is for a function with no parameters. If you if you have parameters, you
but
put.
You still have to name a function. Is what I'm getting at. So I'm a little confused.
Yeah.
So is when you go forward, is that name the same name?
Yeah, he was using name.
Yeah, it's
Whatever you put in the name
whatever
is going to be the name of the
right,
function.
right. So just to make it concrete, let me just pull up the program that was running.
Tradition.
Let's see if I can make this big. Is that visible? Better if I reverse it, maybe?
That's good.
Okay. Okay, so I said I was going to go through side by side the Matlab commands and the program. So here I'm defining function plotnav simple. It's in the file plotnavsimple.m, and its parameters are a file name. Does that answer your question, Doug?
And this function is not returning anything.
The function is not returning anything. If it were to return something, then when I invoke that function, I could put a variable name equals function name, or the square brackets if it returned multiple values.
So the M functions, do they need to be, do the function files need to be in the same directory? Do they have a library directory that they go to?
I always put the functions in the same directory as my data, but you can put it anywhere you want. It understands a Unix style path to, I'm sorry. There is a way to set a path that it searches, but I don't know that way. You'd have to look at the documentation.
Okay, got it. All right.
So you're saying it doesn't return anything? By default, does it return like 0, 1?
Right.
Okay, it does.
Right. Does not return anything.
And in this case, it reads in the data.
Right. And the end of, interestingly, different from most programming languages, the end of the function is the end of the file. You can optionally put an end statement, but by default, it just reads through to the end of the file. It's not an error to reach end of file without a function closing statement. So these are some of what I'm trying to show here are some of the differences from conventional programming and scripting languages. The first block of comments after a function definition is the help text. So if you do help plotnav simple, it'll show this help. So it's a good thing to and again, I'm just using tab completion to finish it, and so here's the 2 lines of text that are at the top of comments at the top of the file. Okay, we'll get to debugging here in a sec. so we just talked about inputs and return value arguments, and about the name. We talked about percent for comments, and here's an example of invoking a function, providing it with some input variables, and assigning the outputs to some other variables. Scripts are text files with a .m instruction. They're like main programs. The only difference that I can tell, and again I haven't used them, but if you don't, when you invoke them, you don't have to put parentheses around the arguments. You can just give the arguments on the command line. But you know, for my money, I think scripts work fine. Documentation, I just talked about the top two lines, the beginning lines being your help text. Debugging functions and scripts. So I've got here the Matlab and the Octave. So this is one of the places that you find some differences between Matlab and Octave, is in debugging. In Matlab, you want to put db stop error, and because what typically will happen is you'll run a function and perhaps you'll have an index out of bounds, array index out of bounds, or variable doesn't exist, or any number of the typical programming errors, and you want it to stop in the debugger when it hits that error, so you can look around, see what variables exist, see what their size is, etc. This is how you cause that to happen in Matlab. So you put this as one of the first few lines. In Octave, you declare it this way, debug on error 1. And you'll see in the sample text, I put a comment saying Matlab error stop, and then here's the db stop error. Matlab actually doesn't mind this statement. Matlab objects to this debug underscore on error. So I had to comment it out to get the script to run on Matlab. But if you're running on Octave, then you would want to uncomment this statement, so Octave would stop in the debugger when it hits an error.
Seems like you could create a dummy debug on error function for your Matlab environment.
That's a great idea. Yeah.
That's
a brilliant idea.
And then your script would work in either one.
I love it. Yeah. Okay, so if we edit our little file here, and we scroll on down, and we try and access A equals M. Let's go for row 1, column 66. I know that doesn't exist. There is no column 66. And then we'll run, and then we better uncomment the Octave debug on error command. And we'll type capital P and then up arrow to use history to get to plot nav simple, so I don't have to type all that stuff. And in momentarily, it pops up, and you can see it's giving a debug prompt now. And it says it's at line 78. Problem is error column index out of bounds, value 66 out of bound 47. So that's a very powerful fault finding technique, is to put those stop on error or debug on error statements at the beginning of your program. Take that out. Okay. So a little more on, since we're in Octave here, we're in the middle of running the script. It hit an error and it stopped in the debugger. So a very useful thing to do right now would be whose. And here are all the variables that are defined, their size, and many of them are size 29,039 by X number. 29,039 is the number of rows in my data sample, and then it's 47 columns across of all the various data types. And there are a few other variables in there that are derived, which we'll go through the code that produces them. But if we wanted to look at the value of tranamps pos at like 29,000, then we could have, we just have to use T, or let's do VHER at row 29,000. And there it is. That's the value in the matrix at that point. So this can be one of the most useful, or a command that's very useful, because it's very common to get your indices off and to step one index beyond the end of an array or something like that. I'll just demonstrate the length command. Length of sorry? Oh, length of VHER. It's 29,039. Size of is another useful command. It's 29,039 by 3. And we'll look at how come it comes to be 3 columns wide here in a sec. But these are the sort of commands that are useful to run in debug mode. dbquit. dbquit exits the program. Okay, so Octave debugging. If you want to add a breakpoint, dbstop, you type the function name in quotes and the line, and then the line number. It sets a breakpoint. db next will step to the next line. db steps into a function. db cont continues from the current breakpoint. And then I talked about Q and Q. Okay, so a useful thing to do might be if we wanted to stop here at line 77, then we can do db stop in Matlab simple again, comma 77, and then we can run the program. And there it is, it stopped at line 77. The same thing, the equivalent thing in Matlab is done by opening up the source file. So we'll open up plotnav simple and we'll step down to line 77, and you just click in the margin there, and it puts a red dot to set a breakpoint. Then we'll run the program, and right away it stops with a green arrow there. Oh, it didn't. I still got that statement in there from that enables Matlab debugs. And we'll exit quit debugging. And open up again. So now it's commented out, and we'll set up the breakpoint at 77. And again, running it from the main shell. And why didn't it stop? Did I double click it? Yeah, I must have double clicked it accidentally and cleared the breakpoint. Okay, so it stopped at our breakpoint, and the little green arrow shows where it is. We've got a step button that'll step you through, and somewhere here I should have variable values. And normally they're just right up the top here. I don't understand why I don't see them. Stopped. Is that a break point? Oh, not a break point anymore. Oh, I did a step and I guess I continued. Okay, so now I stopped at the break point. Oh, and here are all the variables up here. And you can double click on them to open them up. So that's how you do debugging in the Matlab GUI or the Matlab IDE. So I mean, you can see that Matlab's pretty slick. As a commercial product, it really is just top notch. It's an industry standard, and with good reason. But Octave is equally capable, and just maybe not quite as slick. I think. Yeah, so that was all I was going to do on scripting and programming and running commands. Any questions, thoughts on that? Should we take 5 and stretch our legs and because the next section, the next sections are really more about the Matlab language and understanding that script that plots the robot data. So why don't we stretch our legs for 5 minutes and reconvene here in a sec, in 5.
How long did it take? Because this computer seems somebody said it's hot here. This is probably I want to turn on the fan because the problem is that
it also runs the battery.
So that's the reason why I think that was something.
Yes, it's far away from the sound.
Oh, you're right. Good point. I guess I would also turn it off. Yeah, bad news. Okay,
all right,
we're on.
So let's jump into matrices, and because they're your robot data is a matrix. Each row for each tick is a row of a matrix. Indices start at 1, so it's different from many programming languages. The order is row then column, so I is your row number, J is your column number. Here's some special syntax that you'll want to remember. The colon means all of the elements in this row or column, depending on whether it... Actually, colon has a kind of a double meaning, which we'll see in a second, but one of its meanings is all of the elements in this row or column. So this statement here, R equals A of I comma colon, means assign to R, make R a n by 1 matrix containing all of the values of A at make it a 1 by n matrix containing all the values at row I, across all of the columns. And conversely, C gets gets one column, all of the values at row I, at row J. And this is a commonly used. So I'm going to jump back to our example here. One of the things I recommend you do, I'm going to skip over this CSV, well, maybe I won't because it's not in the notes anywhere. The statement CSV object equals import data, file name, comma, 1. Import data looks for the name of a file, a delimiter, and how many header rows it has. So I like to print out my CSV files with header rows because that tells me what's in each column. And there are other ways of importing raw data that's space delimited, and you'll see that in some of the examples in the slides. But that doesn't give you the column headers, and it can get confused because that kind of stuff is dynamic. So what it actually creates is an object or a struct representing the CSV file that has a row of text, a 1 by n row of strings, and then an n by m row of floats containing the data. So here I assign m, the matrix, to be CSV object.data. That's a well-known struct, element name of that struct.
Just a quick question, just
Yeah.
to make sure I understand it. In this case, is CSV object actually meaningful, or is it just the name that you
It's just a name.
Okay,
Yeah.
I just want to make
It's
sure.
not meaningful, no. Import data is the name of the function
Yeah.
that we're using. And then what I recommend you do is put in comments with the meaning of the field names. So field 1 in this example is a serial number, 2 is the uptime of the computer, 3 is GMT time, 9 is the unsigned odometer reading. So that way you know what this script is trying to read.
One quick question, Paul. I noticed that in some of the code that I looked at before the class, they were using pound sign. Is there a difference between the pound sign and the percent sign?
I don't know. I'm not familiar with the use of pound.
Okay.
Yeah, I saw it in your script, and I was like, I've never seen that.
Okay, just curious.
So the import data doesn't have the ability to stuff the header labels into a matrix for you?
Well, it does. It puts the labels in CSV object.text.
Oh, okay, okay.
Yeah, so you can access the labels.
Okay.
The other reason why you want to put this file here, and it's where I was going with this common technique of using the colon to reference a column of data, is m colon comma 2, m colon comma 15. What the heck is that? You really want to assign meaningful names to it, just for your own sanity, so you can read the code and understand it later. So you don't have to do this assigning m colon 15 to tabs pause, but later when you use tabs pause in subsequent computations or plots, you'll be glad you did.
Do they have something equivalent to a define statement? I'm just curious.
Like pound define.
Well, otherwise what I'm saying is instead of like colon comma 15, if you could add, let's say it was colon comma 47, could you just have colon comma HTTSTD?
Good question, I don't know.
You can just define them as variables.
That's true.
Yeah,
Assign
you can do
the
that.
value.
You
Yeah,
can do that.
yeah, I guess so. That's a good
I
point
mean,
too.
you're in a scripting interpretive language anyway, so compiling
Yeah.
doesn't make a difference. You don't
Yeah.
need to pound define. So
Yeah.
up here where you've put all of those, you could just make those variable definitions
That's a good point.
and
Yeah.
then use them symbolically.
Yeah. Say GPS alt equals 42, and then use GPS alt in there. That's a real good point. I like that. Hey, you're helping me improve my my scripting quality skills.
And just from a code perspective, I might just putting a prefix on it so you know it's a constant for something
Mhm,
defined up above.
Yeah, yeah.
Because otherwise they'll start to look like function names.
Yeah,
Or even better, do like pound find us and do them all caps.
Yeah, yeah, yeah. Oh, great thoughts. Okay, so just a quick look here at some of the syntax we've been looking at on the slides. Timesex is the matrix. Colon says says one column, all of the items in column 2. We'll meet this dot star is a multiply everything in the matrix by this scalar. So what we're really doing here, time n colon comma 2 is uptime in milliseconds. So we're multiplying it by 10 to the minus 3 to turn it into seconds. Okay, so this is this use of the colon to represent a column or a row is very common, so you'll want to remember that.
Could you just use like 1,000 instead of each syntax?
Well, sure, you could.
Okay, for those of us that don't think in...
Yeah, this is shorthand, and there are times when you want to do that, and so you'd define a variable like length of array.
Well, I was talking about the multiplier.
It's talking about the multiply by 10 to the minus 3.
Yeah.
You could have easily just said divide by 1,000 and gotten the same thing. Yes?
Maybe. Matlab is not quite as strong on divide because division doesn't make sense in matrices.
Then could I have just done multiply by 0.001
Yeah.
instead of the exponential notation?
Oh yeah, absolutely.
Yeah.
Maybe you could do divide. I just don't remember whether you can divide a matrix by a scalar.
Okay.
Look up the dots.
Do I understand that dot star is an operator?
Yes, exactly.
It's a scalar multiplier.
Yes. It actually means hold that thought. I'll get to dot star in a few slides down.
It's not two characters. It's one.
Yeah, right. It's a 2-character operator, and it has some different meanings depending on whether it's dealing with scalars or matrices. Okay, so actually, to your point, Richard, I forgot about that. I didn't actually know about n, but n means go to the end of the array. So I've been learning some stuff as I've been going through these slides. These slides, by the way, I got off the web from a prof in Germany and at University of Freiburg, and I asked him. I obtained permission to use his slides, and that's who he is, Prof. Aris. And he said, yeah, sure, just attribute them. So it's kind of funky, you know, like 2 days before you're doing a presentation, you like email someone in Germany, hey, do you mind? And he says, yeah, sure. The web is a wonderful thing. Okay, so here's the 2 meanings of colon. One is the wildcard that we just talked about, to select an entire row or column. The other is to define a range. So like 1:5 is a row vector. Or you can use 2 colons between 3 numbers to return as a start value, increment value, and end value. You can also define ranges using linspace, which do help linspace. I haven't actually used it. Here's a kind of a shorthand to assign a constant value to all of the elements in a row. Okay, I just left these slides in because they seemed like they might be useful to you, but I don't use them. So in this script, so I'm just going to skip over adding a row, deleting a row or column. Size we looked at before, length we looked at before. Here's multiplying by a scalar, which we saw, multiplying by 0.001. Here's 2 matrices being multiplied and then added to a 3rd matrix and a 4th matrix subtracted. Here's transposing, the tick mark for transposing matrix, the INV function for inverting a matrix, and there are many more for determining eigenvalues and determinants and all kinds of stuff that I...
How come you just have a star there for multiply, and before you had dot star?
Okay, so I'm assuming here that...
In the top,
oh, here?
yeah.
Good question. Good question. I don't know the answer to that. They both work, but why do they... maybe we can hold that thought again till we get to dot star. That's coming up like here in a couple of slides. Back right here. Okay, so here's a transposed matrix being multiplied by itself in different orders. So here's dot plus, gives you element-wise addition. So dot star gives you element-wise multiplication.
On the previous slide, I suspect that the variable times whatever other variable, both of those are scalars. Yeah. All of the variables here are scalars, and
no,
that's why.
No, not necessarily, because A times B will be multiplied correctly if they're proper, if they're arrays of the proper dimension. Here, like you can multiply 3 by 2 times a 2 by 3 matrix.
Correct. And so in that first one, B equals 3 times A, that will only work if A is a 1 by 1 matrix.
Yes. Yes.
Right?
That's right. It'll give you an error.
That's what I mean.
Yes.
Is that in this particular case, it'll only work when A is a scalar.
Yes. Yes.
Right, you have to be dotted in that case.
Otherwise, if you are doing a multiplication by a scalar for a scalar against something that's not a 1 by 1 matrix, you need the dot.
So let's try that.
Yeah, so 3 times dot A would just multiply 3.
If I have two matrices, if I just use the star, right?
Yeah.
When you're doing matrices, you have to make sure the number of rows and columns are correct, because it's a matrix multiply, not a scalar multiply. So if I want to take a scalar and apply that to all of the elements of the matrix, I have to use the dot, which indicates I'm doing a scalar multiply.
Or an element-wise.
Yeah, element-wise is the better way to say it. And there is a dot product operator also. I don't know, it's probably going to be on a slide. The only reason I know this stuff is I used to use a language called S and S plus and R as well, and it's very, very similar in that particular environment. Yes.
Okay, so I just declared array to be 1, 2, semicolon, meaning the second row, 3, 4, and there it is, 1, 2, 3, 4. So let's try 3 times A.
Oh, it did it.
And it does it, yeah.
Okay.
And then 3 times...
no, try A times 3.
Times A. Okay.
Try A times 3.
A times 3.
I did it anyway. I don't know then.
Yeah. So I don't know what...
Yeah.
But I do know the dot means you're going to force it to be element-wise.
Mm-hmm.
So is an element-wise always going to be with a scalar times a matrix then? Or a scalar and a matrix?
No.
Because how would you have... So element-wise, what if you had
well, like if you had a 3 by 3 matrix and another 3 by 3 matrix, and you wanted 1, 1 to be multiplied by 1, 1, and you come out with a... Or they're better examples.
Yeah.
Element-wise division and element-wise power. Interesting, there's not an element-wise subtraction.
And the dot product is that first one, the inner product. The very top one. That's a dot product.
Oh,
It's an inner product.
okay.
If those are columns, if those are vectors.
Yeah.
Right.
Is the other cross?
Is that true? Yeah. Yes, that's right. So,
What's a cross product? What is it defined? Only for up to 3 by 3, right? Or cross product is only 3 by 3. Is that
I don't
right?
think so. I think a dot product would be any.
No, a cross product.
Oh, we were just looking at dot products and cross products.
okay. I'm going to move on since I'm clearly out of my depth here. It's got most of the string operators that you want: string cat, string strcmp. Look them up. Plotting. Okay, so now let's get to interesting stuff. How we produce these plots. So there's just plot command and then the x value and the y value. It automatically creates a figure. As I said, Octave uses GNU plot, and therefore you have to use the GNU plot commands to zoom back out to the whole thing or zoom in, which are different from Matlab. You can label figures, create figure number 1, 2, 3, whatever. You could create a new figure with the figure number incremented by 1. And a couple more things, and then we'll jump into some examples. So here's a lot of times you want to plot two curves on the same graph, like GPS and absolute abs position, or compass yaw and odometer yaw. So the sequence, how you do that is you do plot, like times x is your x value, give you a time, give you a x value of time, your GPS for your GPS yaw. Then you do hold on and then plot the second value, your abs. If you don't do that hold on, then it just overwrites the first plot. And so this is a point thing. If you think about why that might be interesting, if you're doing it manually, interactively typing plot, and you want to plot something, and then you plot something again, maybe you want a different graph, you can reuse the same figure, and each time you just get a new plot of whatever variable you're plotting. But if you want multiple plots on one graph, that's where you need the hold on command. The legend command lets you add labels that was up in the upper right corner of the. So here's your legend up here. So that's where you put the legend labels in the same order as the plot commands, and then you'll get the right sequence of colors coming up. A few other commands: clear figure, X label and Y label are the two other ones that you'll want. Axes equal is sometimes useful, particularly in XY plots of position. You typically want the X and Y axes to be to have the same scale. But there are other options there that I've never used. You can give the graph different. So the plots that we looked at so far were smooth lines where Matlab or Octave drew a line connecting the dots. But you can do other things, like a plus means put a plus, an X will put an X at the point, a dot will put a dot, an O will put a circle. And then R, there are about 6 or 8 colors you can choose from. R for red, B for blue, G for green. So you can make your colors, so help plot will tell you that. And so here's an example. They declare a line space of 0 to the range 2 pi with 100 steps, and then they plot x and cos of x using red pluses, and then here's an alternate way of plotting multiple graphs on one plot. You can put multiple pairs of x, y things that you want plotted on the same graph, all inside the one plot command. So before I showed the use of the hold on command to let you do your plots on separate values, but it's equally valid to put all of the curve specifications inside of one plot statement. So here they're saying x and cos of x with red pluses, x and sine of x with blue x's, and that produces cos and sine, pluses and x's. Okay, so let's jump back to our program. Okay, so we went through this matrix stuff. One point I want to show here that's valuable. We talked about time secs pulling out that matrix column 2 and multiplying it by 0.001. Here's a trick that you'll want to use. Set start time to time sets of 1. So start time becomes the value in the first element of the time secs vector. Then subtract start time from time secs. The reason you want to do that is the current time is about 1900 billion seconds in GMT time since the epoch. And if you try and plot that on a graph, you'll never see small values like 100 seconds between when interesting events happen, because everything's up in the teraseconds. What this does is it reduces the seconds range down to 0 to however long the run was. And I'm doing the same thing here with adds pos. So adds pos is the best estimate of the current position. I'm taking it as columns 15, 16, 27, and 28. And if we look back up, 15 and 16 is tranadds x and y, and 27 and 28 is GPS northing and easting. So these are going to be in the values of something like at our latitude, where I think we're in about the 4 million meters north and a few 100,000 meters east is the kind of values you'll get. And again, if you're dealing with some range that's only a few hundred yards long, you'll never see the real values. So here I'm creating a new array that is an n by 4. So it's got tranadds x and y, GPS northing and easting for all of the rows. Then take the start pos adds as being the row 1, all of the columns. Then say tranadds pos all rows column 1 is that subtracting start pos 1, 1. So that subtracts the tranadds x from all the values and brings it back to a 0 origin. And so that's how I got to the graph, this one, and you'll notice that we have a 0, 0 point in here. So that technique is how we got x and y and the GPS northing and easting to be based on 0. And then you get sensible values along the axis here instead of like 400,697 point and you can't read the decimals. Okay, I think programming, I'm just going to go real fast over this. I don't have really, oh, sorry, I skipped. Just going down through the source code. Okay, so do a bunch of the same kind of stuff of creating human readable names that contain subsets of interesting data like vehicle yaw, speed, acceleration, the odometer. And then we get into plotting. So we've just gone through plotting in the slides. So here we declare figure 1. We do a clear figure. CLF does a clear figure. Then we plot TranAb's pos, all rows, column 2, which is the TranAb's Y, against TranAb's pos, all rows, column 1, which is TranAb's X. So that gives you your XY plot. We've set it to R for red, and we didn't put X or plus or O or any of those other specifiers, so it'll default to a line. We're specifying line width as 2. Then we turn the grid on so that we see those grid marks across the graph. Hold on so that we can plot a second curve on top of the first one. Axis equal so that the X and Y axes are equal. Then we plot TranAb's pos. 4 is GPS easting in the X position. 3 is GPS northing in blue with a line width of 2. We give the graph a title of position. X, we label the X label, X-axis with Y in M, so it's Y in meters. Y is X in meters. And then the legend is ABS and GPS. And so that's how we got all of this. You can see the legend, you can see the labels on the X and Y axes, you can see the 0, 0 start point, you can see the multiple, the red and the blue graphs.
So which is, I forget, okay, is this is roll off the central axis, is this pitch?
Yeah, pitch is from the front going down, front going up.
Okay.
Roll is from side to side. And yaw is turning around the z-axis. Yeah. And so some of the other interesting graphs are, okay, we're plotting heading in degrees, and here you can see we've got ABS and GPS again, and they're kind of a little bit off, so that's interesting to know.
So do you use Coleman filtering to try to figure out which one to pay attention to?
Well, the Coleman filter produces TranAbs as an output, taking into account odometry, IMU, and GPS. Here, again, we've got GPS versus the encoders this time. What speed? So this is speed in meters per second. Now we know how to label these x-axes. We know how to put the label up there. We know how to make lines green, blue, or red. And we can zoom in and have a look. And so this is real data. And you see the GPS is giving you a kind of a step sort of function in speed, whereas the encoders are giving you a kind of a ziggy-zaggy. Part of what's going on here, part of the reason for that is the encoders are being sampled every 10 milliseconds, whereas GPS is being sampled at 5 hertz. So that's a part of the reason you're seeing different update rates. But clearly, you see GPS kind of lagging behind. See, it's a little high, it's lagging here, lagging up here. GPS is a little behind where the encoders are at.
Now, Paul, just,
So is that lag due to its own internal corrections where it's...
I don't know the reason for it.
Because if you think about it, it would be acquiring samples that ought to be fairly recent.
Yeah.
But internally, maybe it's playing some games.
I'm thinking, hold on, I was thinking, remember when
Some filter.
So let's not go there, because otherwise we'll go off.
Sorry, yeah, thank you. Shut up, Ron.
No, I think you got a good point there.
Okay, so the last thing I wanted to show in the area of plotting. Okay, so here's our plot for the heading for yaw and the speed versus time. One useful thing is sometimes you want two plots that are like one above the other that plot related variables, like northing and easting versus time. So there's a subplot command that says there are two elements in this plot, and this is the one at 1, 1, and this is the one at 1, 2. So you can lay out, you know, like a square, a rectangle of plots, of related plots, and then within that subplot, we've seen all the commands. And you, an example of that is here. So this is northing and easting versus time, and this is useful because the XY plot, okay, it tells you where the robot went, but it doesn't tell you when it was at each place. And sometimes that matters because the vehicle might have stopped for a while, or you know, there's various, you might be trying to correlate it with a yaw reading or with a PID value, a plot of PID values over time. So sometimes if you see the robot behaving weird in an XY plot, you can find, you know, note down the X and Y, look them up on the northing and easting, and say, okay, here's where I was at, and it was at time 62. Then you can go into other plots and see what was happening to your PID loops at time 62. Okay? So that was plotting. And really that's the bulk of the Matlab stuff that I plan to go through. I'll just show you what's in the slides just for completeness, and there's a couple of significant points, but be thinking about as I skip forward whether there are any like higher level questions.
So as you're in the back of the vehicle, you know, white knuckle, what plots are you looking at?
I'm looking at where it thinks the road is. And if it like is veering off into the grass, then I'm really worried. Okay, so it's got Matlab, the language has got it's got if statements, and here's the syntax. And there's like 111 slides in the original. I put a link to the original, so I've deleted a bunch of stuff that I thought you wouldn't want. But if you're going to do more with Matlab than robot data plotting, then you might be interested in this kind of stuff. Switch, while, and for, where you can continue, comparison, including comparisons involving matrices. If any element of the vector is non-zero, or all, if all is zero, can sometimes be useful. There's the relational operators, Boolean expressions, and conventions regarding camel case. Miscellaneous commands like clear, a variable, close windows. Displaying can be useful. One of the things that I do is, right before I start plotting, I plot start time. Remember, I isolated start time and subtracted from all the values. Well, if I want to go and dig down into the data, like in Excel, I need to go back to what GMT time was this. So by plotting the start time, I can just add that to whatever time I'm interested in, and I can find my way to the data in Excel. These last couple of slides are just how to read and write files that are space delimited without headers. And that's it. So, thoughts, questions? We've gone over a lot.
What is
Camel case?
Or camel case?
Uppercase for the beginning of each word, and then lowercase So my favorite variable with M, F, and V capitalized, and the rest lowercase.
Oh,
Because it has
You know, one hump lump, one hump wump kind of thing.
So camel case implies the first letter is going to be lowercase, but then the next word.
No.
No,
It doesn't imply anything about the first letter, but it does imply that each word in a multi-word variable name, the subsequent words begin with a cap.
Okay. There should be a word for when you have a lowercase versus an upper as the first letter, like in Java. What is it? I can't remember if it's variables. Oh, shut up.
It's a programming convention.
Yeah.
So Octave, Matlab, two different programs for running the Matlab program, for the running Matlab scripts. Octave free, Matlab cheap and good. Can't use Matlab for commercial, obviously commercial uses or professional uses. You know, that would be like, you know, that'll get you in trouble, right?
Do they have a hobby license for people that are not students?
They do not have a hobby license.
Could I mention one program worth investigating that Will and I use, and I can't remember how good it is, but it's called Scilab, S-C-I-L-A-B.
Yeah, I've read about it. Simulator.
Yeah, and it has a lot of math CAD functionality, but it's not probably as compatible, I think, with Octave. How do you say it?
Octave, yeah.
Octave. Okay. Anyway, I think you'd be better off there, but Scilab has a fairly nice IDE and editor and stuff like that. So it's an interesting program.
There are 3 or 4 of those editors around. That is one. Yeah. Any other thoughts?
Have you, in your new job, have you used this to tune Kalman filters, and have you used it for SLAM?
Neither. I've not used it for either. I've just used it for plotting, and then I did make a, I did use Simulink to create a model of a vehicle, including its steering and its weight and gas pedal and engine and whatnot, and use Matlab to plot some of the outputs of the simulation of that model.
I mean, for Kalman filters, I've seen a lot of scripts for that. I'm curious how compatible they are. And obviously, you have to have a data set, and then you run it against the data set and tune it.
Yeah, there are Kalman filter code that you can get that's already written in Matlab.
Yeah.
So, we try it. Well, I hope this is useful to you in you know, plotting at a higher level and getting more value out of the data that you collect off of your robots and seeing what your robots are really doing. Thanks, guys.
By the way, I looked it up, and the pound sign in Octave is an equivalent to the percent sign.
Really?
Yes, but only in Octave.
But only Octave, so I see. So that's one of those things where you should use percent.